one here?
Yeah, number 13.
Okay, let's look. No, that's what, no worries. Let's look at 13 and then 7.4. Okay, that's impossible.
Like 7 and 8, like I can't. I know the shape of the graph, but I can't figure out where it starts.
Okay, so let's take a look. Alexander wishes to put a new window in his home, again with windows. Is this the 13, Janelle?
Yes.
Okay, perfect. He wants the perimeter of the window to be 160 feet. Fine. The graph below shows the relationship between the width in feet and the area of the opening again. Okay, so we have the width and the area. Complete parts A and B below. Determine the domain and the range of the relation. Excellent, excellent, excellent. Why are they saying relation? It's wrong. It's a function by the vertical line test, but they say relation. Okay, I disagree with that, but that's okay. So, notice that these points are open points. I cannot use a bracket when I see open points. So I see that the domain goes from 0 to 80, but not 0 and not 80. So when I write the domain of this function, it's a very good exercise. When I write the domain of this function, I have to put parentheses, 0 and 80. I cannot use a bracket at either end, only because I have an open point, Okay? Now, I don't want to go back to 12 to show you that those two, if you remember, because it will give us another problem. So let's finish this problem, then we'll go back to 12 so you can see those are full points, and then if they were asking the domain, I would have had to use brackets at both ends. So here, I have to put parentheses, and I have to put 0, and I have to put comma 80, because the endpoints are not included. Then the range. Again, because these 2 points are not included, I cannot include the 0 with a bracket. And I'll go all the way to 1600. So when I write the range for this function, I have to write parentheses for 0. But at 1600, the point exists. It's not an open point. Therefore, I have to use a bracket. See, if you don't do the work, you will not have questions, most probably. So careful how you enter this. So I have 0, 1600 with a bracket for the range. Explain why the domain obtained in part A makes sense. The width of the window must be greater than the width of the window must be greater than half of the perimeter. So let's think a little bit. So wishes to put a new window. I have to create he wants a perimeter. Okay, so I'm assuming the window, it doesn't say, but I'm assuming it's a rectangle. He wants the perimeter of the window to be 160 feet. The graph shows a relationship between the width and the opening area of the window, which is the area. Okay, so here's the window. And here's the length. And here's the width. So the perimeter, so I'm going to say this is the x and this is the y. The perimeter is 2x plus 2y. And they're telling us that this has to be 160 feet. Was it? Yeah. Now, when we simplify dividing both sides by 2, I get x plus y equals 80. So now the question here is, let's read it again, because it's a little bit convoluted here. The width of the window must be half of the perimeter, less than Well, this is the half of the perimeter. X plus y is half of the perimeter. Of course, both of them, the length and the width have to be less than half of the perimeter. Because if this is half of the perimeter, then y is 0. If this is half of the perimeter, which is 80, then this is 0. So both have to be less than. X and y have to be less than half of the perimeter. Because if any of them is the perimeter, they half of the perimeter or more, we don't have a window. Okay, so the width of the window must be less than half of the perimeter and greater than, of course, 0. Otherwise, the area of the window would be 0 or negative. So the width must be less than half of the perimeter. Both the width and the length have to be less than the perimeter. And greater than 0, of course. Otherwise, the area would be 0 or potentially negative. That's correct.
Thank you so much.
Is this clear? Now,
Yes.
going back for a moment, see this graph. This graph has full points because it has full points. If we are asked to find the domain of this graph, we have to put a bracket at 0 and a bracket at 40. If I'm asked to find the range of this graph, I have to put a bracket at 0 and a bracket at 400. So again, the domain is measured from the leftmost point till the rightmost point. Both points exist. The domain of this graph will be bracket 0, comma, 40, bracket. If I'm asked to find the range for this graph, it starts at the lowest point I can see, and it goes all the way till the largest point I can see. Because both points here exist, or even just one exists, it doesn't matter. But because they are full point, I have to use a bracket at 0 and go all the way to 400. The point at 400 exists, so both will be brackets. Bracket at 0, dot, 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 400 with a bracket. By comparison here, this point exists, but these two do not. So parentheses 0, 60, and parentheses 0 all the way up to 900.
That makes sense.
Very good questions. Very good questions. Thank you.
I have 7 and 8, and they should be simple, but like I had to guess to get the right answer on 7 and 8. And
From
I
the
don't know.
same section.
Yeah.
Okay. Jalaya, did you have the same thing from the same section or a different question? You had 7.4, right?
At 7.4.
Okay. So, sorry, so we can finish with 7.3. Rachel, Rachel,
Just one of them would be fine. I just want to see how you.
you're talking about 7 and 8, Rachel?
Yeah, just whichever one.
Okay. So see if this is close enough.
Yes.
Okay. So let's take a look. This is a very good question. So y equals the absolute value of
For the
x.
life of me, I couldn't guess the right one.
No, I don't want you to guess. I want you to follow me here. Okay. If you remember last time we looked at y equals the absolute value of x, and we said this is a v function. Please look at the previous notes. They are very, very, very important. So this is the graph of the base function. Y equals the absolute value of x. This is the simplest absolute value function. Now, what happens if I change this into this function? It means that I pull down both sides at the same time down to -8. So the graph will look like this. 1, 2, 3, 4, 5, 6, 7. All parallel, completely the same. So this is y equals the absolute value of x minus 7. Now, what happens if I have y equals the absolute value of x plus 2? What do you think will happen now? If I want to graph this, what will I do?
I had +1 and it wasn't on 1, so I don't know.
So if the negative 7 pulled down the original graph here, what will this do?
Pull up.
Exactly. Exactly 2 units up. So this is going to be the graph of the absolute value of x plus 2.
My example of y equals x, absolute value of x plus 1 did not have it go up to the 1 place. It was at like 0.5.
Not
going up.
Can I open your assignment? So let me
That's
just
fine.
let me finish this one. So it cannot go up, it cannot reverse direction, it cannot reverse direction. So this is the only one. It must go down 7 units according to my example. So 2, 4, 6, and it's right in the middle between 6 and 8. So C is the correct graph.
Oh, never mind. I just realized that mine are in 2. Like each line is 2. So never mind.
Good. We need to look at this example, though. Number 8. Very important example. So y equals the absolute value of x plus 4. Okay. This is what I showed you here. Vertical shifts. Vertical shifts. This is not a vertical shift. So let's understand why. Notice that the absolute value of x is the same. It does not change. What changes is the outside of the absolute value of x. But this is a different story. What changes from the base function is inside the absolute value, not outside of the absolute value. When the change is outside of the absolute value, there is a change in y. When the change is inside the absolute value, is a change in x. One more time. The absolute value of x is this graph. If outside of the original graph, I go up or down, +2, -7, this goes up 2, this goes down 7. But this one is a different story. This is not a transformation on y. It's a transformation on x. What does it mean? For y equals the absolute value of x, can anyone tell us what is the x-intercept of this graph?
Zero, 0.
Thank you. Before we discuss this graph, for this graph, can anyone tell us the x-intercept? Remember, y has to be 0. For the x-intercept, y has to be 0. 0 equals the absolute value of x plus 4. What should x be for this to be 0?
-4?
Exactly. So the x-intercept of this graph is -4, 0. Stay with me, please. So again, the original base function, the simplest of the simplest of the simplest, absolute value function, is this. And I mentioned that this is not a vertical shift, but it's a horizontal shift because I am changing the x, the inside of the function, not the outside. The original graph has the x-intercept here, as you mentioned. The new graph has the x-intercept here. at -4. So therefore, this is the graph. It's a horizontal shift. You would have expected this to move to the right. No, it moves to the left because that's where the x-intercept is. If I move it to the right, 4 plus 4 is not 0. But -4 plus 4 is 0 to find the x-intercept. So y equals x plus 4 shifts the original graph 4 units to the left. Can anyone give us this example and tell us y equals the absolute value of x minus 3? Where will the graph go? Is it a vertical shift? Is it a horizontal shift?
Horizontal shift.
It's a horizontal shift because we changed the inside. But is it to the left now or is it to the right? And you only have to think in terms of the x-intercept.
Right.
To the right, exactly. It goes to the right
Opposite.
because only 3 minus 3 is 0. That's the only x-intercept.
Thank you so much with that, because I was just guessing. I'm like, I don't want to guess on the test.
So, in summary, vertical shifts are very easy to understand because it's what you would expect. Why? The absolute value of x minus 7 pulls down the graph 7. The absolute value of x plus 2 goes up with the graph, shifts the original graph to up. But when it comes to changing or shifting left and right, we have to think a little bit. And how do we determine and how do we remember this? Because I don't want you to memorize. Okay, x plus 4 is to the left. But why is it x plus 4 to the left? X plus 4 is to the left because 4 plus 4 will not be 0. -4 plus 4 will be 0. That's why it's this point. Why is this to the right? Because it'll be 3 plus 3. 3. 3 plus 3 is 0. -3 minus 3 is -6. The absolute value is 6. It's not 0. So that is the reason why. X minus 3 shifts the graph to the right, 3 units, and x plus 4 shifts the graph to the left, 4.
So if it's a positive, it goes to the negatives, but if it's a negative, it goes to the positives.
You can remember it like this, but you'll not remember it forever. What you should remember is, where is the x-intercept here? And the x-intercept here is at 3, because 3 minus 3 is 0, and I get y equals 0. If I put -3, -3 minus 3 is -6, the absolute value is 6, is not 0. Same thing here. If I put 4 plus 4, I will get 8. It's not the x-intercept. But -4 plus 4 is 0, which is the x-intercept. But you can remember it like that if you like. Of course.
I appreciate you, because that I didn't think it was hard, but it was hard.
So,
And I'm just sitting there guessing, and so you can take away the guess. Thank you.
thank you. So at this graph, just remember, put this point in the graph. You will not get 0. When you put 4 in, you get 8. So A cannot be the right one. This is not even a function. I won't even look at it. This is not even a function by the vertical line test. It's a waste of time to even look at it. Let's look at D. If I plug in -4, do I get 0? Yes, of course. When I plug in x equals 4, I get 0 for y. Because this shifts the graph to the left 4 units. So D is the correct answer. Any questions? Okay, here's another thing. We go to y equals, clear whatever you have, and let's put in this. Math, numbers. Tell me if you want me to record this. Okay, numbers, ABS, absolute value.
I think someone said yes.
Okay. Okay, so please, Janelle, if you want to turn off your camera. Thank you. Sorry about that. Let me share first and then record. Record. Okay. Good. So in y equals, which is this, I go to math, I go to numbers, and I select ABS, which is the absolute value. And this is the base function. Now tell me which graphs do you want to graph from the ones we looked at. The absolute value of x minus 7, the absolute value of x plus 2, the absolute value of x, you know what, let's put all of them. But you have to be very careful and look to see what is happening here. So this is the absolute value of x, and then outside minus 7, and then the absolute value of x, and then outside plus 2, and then the absolute value of x plus 4. And remember, this will be a left shift of 4 units. And I'm going to put in also the last one, which is x minus 3. So look at the colors now, please. Blue, red, black, I don't know, pink, and green. It will go very fast. Okay? So blue, red, black, pink, green. It will go very fast when I click graph. So I'm going to go to zoom and select 6. Remember, 6 is the standard viewing window when we talked about that. Negative 10, 10, negative 10, 10. So when I hit on graph, again, blue, red. So this is going to be a downshift. This is going to be an upshift, left shift, right shift. Ready? Down, up, left, right. So the original graph, down the absolute value of x minus 7, up the absolute value of x plus 2, left the absolute value of x plus 4, right the absolute value of x minus 3. Good. I can stop this now. Good. I will post it up after class. Okay, thank you. Do we need anything else from 7.3 or we may wait enough? We move on to 7.4. No, I'm will answer any question you have. Are we finished with 7.3? And this is valid for all functions we looked at. These rules are valid for x squared, are valid for the square root of x, are valid for the absolute value of x. For every function, they are the same rules. If it's outside up, if it's outside down, or if it changes x, careful, you have to think if it goes to the left or to the right. Okay, am I assuming then correctly that 7.3 is done?